Page 456, number 37. Represent the complex number graphically and find the standard form of the number. And we're given 2 times the cosine of 120 degrees plus I times the sine of 120 degrees. Okay, first of all, to represent this graphically, we know r, which is the radius. So we know this point's going to be 2 units away from the origin. And we know theta, so we know it's going to be at an angle of 120 degrees. So if I start here at the x-axis, go positive direction, this is 90 degrees. 120 degrees is about right here. So if I make a point 2 units away from the origin, there's my complex number. So we've taken care of the first part, represent the complex number graphically. Now to find the standard form of the number, let's make a right triangle here. I know this dimension is 2. I know this angle right here is 120 degrees, which means this angle is 60 degrees. Okay, now I can use SOHCAHTOA. I can say the sine of 60 equals y over 2. I can say the cosine of 60 equals x over 2. But I know that this is a 30, 60, 90 special right triangle. So I know the shorter leg is going to be half the hypotenuse. So x is going to be equal to 1. And actually careful, it goes to the left, so it's negative 1. Y is going to be equal to the shorter leg times the square root of 3. So y is going to be equal to the square root of 3. Now, the standard form of the number, remember this is the real axis, this is the imaginary axis. This number goes 1, negative 1, excuse me, in the direction of the real axis, plus square root of 3 in the imaginary direction, so I times the square root of 3. So there's our graph, and here's our standard form. Now another way to find that standard form, and a good way to check our work, is to take this 2 and just distribute it throughout what we have here. So I'm going to get my calculator out, and I'm just going to type 2 times the cosine of 120 degrees. And that gives me negative 1, the first part of my answer. Then I'm also going to type 2 times the sine of 120 degrees. And that gives me 1.73, which is equal to the square root of 3. So by using the distributive property, it verifies that my graph and my answer are correct.